Mental well-being is a silent pandemic. According to the WHO, depression and anxiety cost the global economy over $1 trillion every year. It's time to make a difference. Learn how to enhance your lives through a masterclass from Founders Wellbeing and my good friend Sandeep Rao on mental wellness. Visit founderswellbeing.com/masterclass to enroll and enter TLJ20 for a 20% discount. Be a better version of yourself and make an impact. The ISA QB Software Architecture Gathering is the international conference highlight for all those working on solution structures in IT projects, primarily software architects, developers, and professionals in quality assurance, but also system analysts who want to communicate better with their developers. A selection of well-known international speakers will share their practical knowledge on the most important topics in the state-of-the-art software architecture. The conference takes place online from November 14 to 17, and we have a 15% discount code for you. Enter TLJ_MP_15 for 15% discount.
If they want to get value from their data, generate data-driven value, and they want to do that by applying analytics and AI in almost every aspect of their business, they need to utilize data from all aspects and all touch points and all applications inside the company and outside. If they have such a mission and they want to do that reliably, resiliently, and do that at scale fast, then they've got to consider data mesh. It's all about really unlocking the value of the data.
Hey everyone, my name is Henry Suryawirawan, and you're listening to the Tech Lead Journal podcast, the show where I'll be bringing you the greatest technical leaders, practitioners, and thought leaders in the industry to discuss about their journey, ideas, and practices that we all can learn and apply to build a highly performing technical team and to make an impact in your personal work. So let's dive into our journal. Hello again, my friends and my listeners. Welcome to the Tech Lead Journal podcast, the show where you can learn about technical leadership and excellence from my conversations with great thought leaders in the tech industry. And you're listening to the episode number 107. If this is your first time listening to Tech Lead Journal, subscribe and follow the show on your podcast app and on LinkedIn, Twitter, and Instagram. And if you'd like to support my journey creating this podcast, subscribe as a patron at techleadjournal.dev/patron. My guest for today's episode is Zhamak Dehghani. Zhamak is the founder of Data Mesh Concept in 2018 and since then has been evangelizing it to the wider industry, including writing her latest book titled Data Mesh. In this episode, we discussed in depth about the data mesh concept, which is starting to become an industry trend nowadays. We started our conversation by discussing the current challenges working with data, such as the outdated data centralization approach, and why the current data tools are still inadequate. Zhamak then described data mesh and why organizations should adopt it to generate data-driven values at scale. Zhamak then explained the 4 core principles of data mesh, which include domain ownership, data as a product, the self-serve data platform, and the federated computational governance. I really enjoyed my conversation with Zhamak, learning the data mesh concept in depth, which has been something I would love to learn more about, and this episode taught me a lot about it. If you also enjoy listening to this episode, will you help share it with your friends and colleagues who can also benefit from listening to this episode? My ultimate mission is to spread this podcast to more listeners, and I really appreciate your support in any way towards fulfilling my mission. Before we continue to the conversations, let's hear some words from our sponsors. Devternity is the top international software development conference with an emphasis on coding, architecture, and tech leadership skills. The lineup for this year is truly stellar and features many legends in software development. Names such as Robert Uncle Bob Martin, Ken Beck, Scott Hanselman, Venkat Subramaniam, Kevlin Henney, Alan Holub, Mary Poppendick, and many other prominent names, including some of those who have also appeared in this podcast before. The conference takes place online, so you can enjoy it from the comfort of your couch. We spoke to the Devternity organizers, and I'm happy to share that Tech Lead Journal has got the 10% discount code for you. Enter the promo code AWSM_TLJ when you purchase the ticket on devternity.com. Here's the promo code one more time, AWSM_TLJ. Depending on the time when you purchase the ticket, early price is still available. See you there. Today's episode is proudly sponsored by Skills Matter, the global community and events platform with more than 100,000 software professionals. Here, members can organize their learning experiences around the technology topics they care about most. You get on-demand access to their latest content, thought leadership insights, as well as the exciting schedule of tech events running across all time zones. So whether DevOps or data science is your buzz, or you're a fan of functional programming or all things cloud, you can make real connections with people who share your interests. Head on over to skillsmatter.com to become part of the tech community that matters most to you. It's free to join, and you will find it easy to keep up with the latest tech trends. Hello everyone, welcome to another new episode of the Tech Lead Journal podcast. Today I'm so excited to meet Zhamak Dehghani. She was last a Director of Emerging Technologies in ThoughtWorks. She was there probably around 11 years. I know Zhamak following her work when I was working in ThoughtWorks as well. So she was part of the Technology Radar Committee and always come up with all these emerging technologies. And recently, in the last few years, Zhamak came out with this concept called data mesh. I think it was around in 2018, if I'm not wrong. Since then, the data mesh concept has taken a surprise by many people and many people rave about it. So today we'll be talking a lot about data mesh, and I'm really looking forward to have this conversation with you, Zhamak.
It's a pleasure to be here, Henry, and thank you for that perfect pronunciation of my name.
Oh, surprise. Okay.
Yeah.
So, Zhamak, I would love to probably know more about your career. So, I always start to ask my guests to share their career journey or any turning points or highlights in their career. Maybe if you can share a little bit about yourself.
Sure, I'd love to. I guess my journey is filled with detours and going to new places led by curiosity. So I started as a software engineer. For the first 14 years of my career, I worked in deep tech R&D companies where they were building a technology product. So I did distributed systems before cloud and large scale distributed systems was a thing. Build monitoring and observability from scratch, building streaming systems, building databases that basically get signals from critical infrastructure, analyze those signals, them into reports and so on, the full stack of what a real world distributed system could look like. And I did that on multiple operating systems, various flavors of Unix and HP Tandem and Windows and so on. That really gave me a good insight bottom up to the technology stack. I realized that a lot of technologists today maybe start with web development or app development, and they don't get the opportunity to really look inside the kernel and how to do system programming, how to build protocols. I did all of that, which was awesome. And then I took a bit of a detour. I went to hardware for a little bit. I worked for a company that was building various hardware from scratch. We were building the firmware on digital pen systems. And that was interesting as well. Again, a lot of great learnings. I had to build embedded firmware. And then another detour, I came to consulting with ThoughtWorks. As we worked at ThoughtWorks, we worked on kind of larger scale execution. So that led to microservices and again, building large scale, distributed solutions with microservices and that ecosystem. I did quite a bit of work in that space for quite a while. And I was excited about service mesh and Kubernetes and all of the technologies that's really made it possible. And as you said, about 4 years ago, I kind of started putting my nose into the data space. To my surprise, the world of data was far from the agility and nimbleness and autonomy and distribution decentralization that we see in the app dev world. It's slow moving, it's based on paradigms around centralization of data and middlemen moving data around. And that was a very sad observation, to be honest. And I thought, okay, I could be the little kid who points to that naked emperor, and I don't mind doing that, even if I get attacked. So I started talking about, okay, how can we shift the paradigm? What are the pain points? Wake up, people. And yeah, and data mesh really came as a hypothesis, as a question with some answers, some basic answers. Since then, I've been kind of building it, evangelizing it. And as of 2 weeks ago, I decided to start a company to build a product, a technology, deep tech kind of dev product, developer facing product that is going to make it so easy to kind of work with data under the data mesh principles to really show the world a different way of doing things and enable developers, most importantly.
Wow, sounds really exciting. Yeah, I saw your post about quitting ThoughtWorks job. It was surprising to me, but I think looking at the opportunity of investing more effort in building the tools about data mesh, I think that will be definitely crucial and will help a lot of people. But before we go into this exciting journey, I think first of all, the topic of this conversation is about data mesh. And you wrote a book with the same title, Data Mesh, with the subtitle of Delivering Data-Driven Value at Scale. So maybe if you can share a little bit, what did you actually see the problems when you were working with the data? You mentioned about some old ways, paradigms, centralization, and things like that. But what kind of challenges and problems when you work with the data problem during that time? And maybe if you can give an overview how data has always been approached in the delivery or in the day-to-day development.
Yeah, that's a good way of positioning data mesh. The problem that I saw was that we had an assumption that to get value from data, and value being through BI, business intelligence, through reporting, through training machine learning models, or all sorts of analysis of data, data needs to come and get modeled or raw and get centralized. That was a response to a siloing of data in application databases that really didn't allow cross-cutting analysis of data across the applications. But that centralization, that idea around centralization had led to a very fragile, very slow moving architecture and bottlenecks for really getting value from data. So, what are the points of fragility that causes so much waste? Those are data pipelines. So, to centralize data from applications, we have this concept of ETL, ELT, extraction of data from application databases. I think it's one of the biggest crimes that we can do with the architecture. It's so intrusive, right? Because there's no contract, there is no abstraction. So you have constantly breaking very task-oriented, job-oriented, elaborate pipelines, like complex pipelines, moving stuff around and converting them, putting them from one sink to another sink. And that is a very fragile and it causes a lot of waste. By the time the data has popped out of the other end of the pipeline, the source has moved on and you got problems to solve. And then on the other hand, you have this big bottleneck. So the assumption that there is a data team responsible for the data from everywhere and they put it in a warehouse or lake, it is a flawed assumption in an organization that needs to move fast, needs to share data more peer to peer. They become a bottleneck. The team and the architecture itself become a bottleneck. So you have frustrated users, data users. They can't find the data they need. They can't access it. They don't trust it. By the time data got made available to them, the source has moved on. Data people in the middle that honestly, I have all the love and empathy for them in the world, that they have been given this impossible task of getting data from people that have no intention of sharing data, giving it to people that they have no idea how they're going to use it, and are stuck in the middle, like cleaning data, watching and shoveling data with no really purpose, to be honest. They are under a lot of pressure and they don't perform. And then the applications really don't have much of a visibility or even opportunity to use that data. They just put data out to put it in the databases and use it for their operational needs. And they're never in the conversation in analytics. So they're isolated from real application of possibility of ML embedded into their applications, but becoming analytical data users because they've been got just put aside from this data world. Yeah, so fragility, long lead time from data to value, bottlenecks, all of that are major problems that you see with the past paradigms.
I think in my career so far, I've experienced things like, for example, big giant database where you have vendor database like Oracle, SQL Server, right? And then we move into the paradigms of data warehouse concept where you have another set of tools where you pump the data from the OLTP database into this analytical database. And then in the last maybe 10 years, we moved to another concept called data lake, where you probably centralize raw data, put it there. And from there, you move into different data marts, maybe, or different small data warehouse. And now we move into this cloud model where we also see cloud technologies helping. I'm familiar much more with like BigQuery and Amazon, maybe you have Redshift. So if you see all this historical, the unique thing about it, like you mentioned, the centralization, why people actually move more towards centralization rather than the decentralization part.
Yeah, it's easy to get started with, right? When your problem space is new or solution space is new and you require specialization, you've got a new set of tools, a new ways of working with data, You can't leverage your majority of organization. You can't really push the responsibility into every team. You have to centralize the specialized people. And also it's easier to control and easier to get started with, like we know, right? Any startup start building an application or solution, we say like, start with a monolith, find your market fit, and then break it down because decentralized distributed systems are inherently complex. So there has to be a pivotal point that the complexity of your environment increases to the point that centralized simple solution does not work anymore. And I think the data warehouses or lakes or lake houses as an architectural paradigm, not so much as an underlying technology, they've been suitable for this world that the data wasn't ubiquitous. Perhaps we weren't capturing data from every touch point. The data wasn't being used in every single application and domain. And having a centralized team and a centralized technology stack to deal with it was acceptable. But we don't no longer live in that world. We've passed that pivotal point of complexity.
So you mentioned about this point about operational versus analytical divide, where the application team probably just dump data into database, and maybe there's another set of data analyst, data engineer trying to get the data from those databases and put it in a central place and getting insights. There are a lot of complexities, definitely. But I think in the last few years, we also see a lot of advancement in data technologies. So I think I saw in your book and presentation, you have this one slide where probably there are so many different technologies. The logos are too small. Why those tools still couldn't solve this kind of problem? Because it seems like there are so many advancements.
Yeah, that's a very good question. I mean, the tools are solving niche problems. Oh, actually, clarify with an example. That nevertheless, they are created for an operating model that at the end of the day is pipeline data, transform, put into storage, layer with metadata, or sprinkle ML on top, and voila, you get value on the other end. So they have been organized around this very centralized pipeline model at a very macro level, right? If you zoom out and if you start sprinkling these tools to an overall kind of big picture meta architecture, that's what they're organized to do. They're organized to solve ingestion problems. They're organized to solve big, hairy pipeline problems. Airflow, like those sort of technologies, they're designed to solve the big data storage or parallel processing problem. So unless you change the operating model and that meta architecture, no matter how locally you optimize a particular solution, we're going to optimize and solve the really hairy centralized data pipelines. You're still going to have a hairy centralized data pipeline. You get a little bit better at maybe detecting the errors or connecting to more resources, but ultimately you're still stuck in the past paradigm. And those fundamental assumptions that need to be invalidated and need to change remain. In fact, people who are deeply in the data space and try to use these tools, they struggle and they suffer. They've got this massive landscape of fragmented technologies that frankly work really with difficulty with each other. And they have to work with them, they have to integrate them themselves. The cost of integration of these technologies into a meaningful, scalable solution is very high. I mean, if you look at every vendor on that diagram and if you go to their connector pages, there's businesses built around just custom proprietary connectors to yet another data source, yet another data sink. Lack of standardization is just mind-boggling in this space. So it's like the Tower of Babylon, like it's just falling apart. In my mind, it just feels like nobody speaks the same language to a large degree. Tools are built to solve a very custom solution, and the foundation of this house is about to fall off. So you still have a broken foundation. I know I can be very polarizing as I describe this because I'm very passionate about let's fix the foundation. Let's rethink our operating model.
Totally makes sense because, yeah, the way you mentioned about cost of integration, I can imagine every data products that I see, you will see all these integrations. Then the more, the better. After you do
Yeah.
it, actually the investment, you kind of like lock down and you put so much effort and maybe money to actually move your data. But eventually, if you need to switch, also the costs for you to move the data out to different technologies, I think that's also painful. So I've been into some of these kind of projects. I think I agree with you about that problem. So you invented this data mesh, right? So if I may describe data mesh from your book, you mentioned data mesh is a decentralized socio-technical approach to share, access, and manage analytical data in complex and large-scale environments within or across organizations. So there are so many interesting topics, but the first that I picked is actually you mentioned it as a decentralized socio-technical approach. So tell us more about this.
Sure. It actually started as an architecture because I am a technologist. So I kind of apply the lens of technology to solve problems. So I saw this as really an architecture to organize how we decouple and how we break down this big problem of how I get value from data. But very quickly, I realized, as we know, Conway's law and just real life experience, technology and architecture mirrors and get influenced by the way we organize our organizations and teams. So very quickly, I had to self-correct. No, this is not just a technical solution. No, this is not just an architecture. We've got to rethink the organization of teams, the modes of communications, the contract for data sharing between the teams, and the responsibilities. Like data product owner was a new role that we introduced. So hence it became a socio-technical, as in we try to find excellence in our solutions involving the interaction of people and teams and the technology. Some people say, oh, is it techno-social or is it the socio-technical? I don't really care which one comes first, as long as they're both involved. Hence the word.
Thanks for sharing that. It seems like the Conway's laws is really like a true principle in many software design or architecture, right? So I think data mesh is probably one of it. And you mentioned that it is an approach to solve complex and large scale data problems. So does it mean that not everyone will need to go to data mesh since the beginning?
Yeah, I think at this point in time, I mean, I answer usually this question by saying, well, at this point in time, if you don't have the organizational complexity, if your lake or lake house or warehouse model is not a bottleneck for you, if the centralized data team is doing a great job and everyone's happy, well, why introduce a concept that's rather complex? It creates kind of system complexity. So, yes, the short answer is yes, it's not for everyone at this point in time. And maybe in future, technology advances, our thinking, our approaches, our process advances in a way that bootstrapping with data mesh is as easy as bootstrapping or even easier than it centralized. So then at that point, you say, well, this mesh is for everyone because the maturity of support of the environment has reached that level of maturity.
So you have shared all these problems, challenges that you saw before, and you came up with this concept. But for those people who are already in this state of complexity dealing with their data, either data architecture pipelines and things like that, or an organization that is very large scale, maybe global, where they have all these data challenges, maybe tell them what are some of the reasons why they should consider moving to data mesh. So maybe in business value or maybe in some kind of more impact value driven kind of a benefits.
Yeah. Just simply, if they want a subtitle of my book, if they want to get value from their data, generate data driven value, and they want to do that by applying analytics and AI in almost every aspect of their business, and they want you to do that, they need to utilize data from all aspects and all touch points and all applications inside the company and outside. If they have such a mission and they want to do that reliably, resiliently, and do that at scale fast, then they've got to consider data mesh. It's all about really unlocking the value of the data. So let's give a real world example. If you are in a particular part of the business, let's say I use this example in my book of a Spotify-like company. I called it DAF Inc. It's a digital streaming company. And if you have a team whose job is really to create immersive musical experiences personalized for every moment of every person in the world, depending on what they do, that team constantly comes up with new hypotheses on how to use data about music and artists and listeners and their behavior to create a more immersive experience, more personalized to that moment in life. Every one of those hypotheses, they require discovery of the data and access to the data. So are they going to be more successful to be able to discover and get access to the data and even ask people to provide the data if the data is not there, if they were working in a peer-to-peer fashion? Or are they going to be more successful if it was a centralized team in between all parts of the business? So as an example, if the playlist team, the generalist immersive playlist, want to create targeted music for people if they're doing cycling or running, are they going to be more successful to go and talk to teams that are taking care of partnership with cycling platforms directly and say, look, we need to see what people are responding to when they're on their pelotons, I suppose, as an example. Or are they successful if they say to a middleman, data broker team, and say, look, I have this hypothesis. So as all of these other teams that you need to now put on your centralized backlog and plan somewhere and get me to the data that I need. That doesn't scale. So imagine your organization, imagine the missions and the values that can be enabled through the data, and see if you have bottlenecks that need to be addressed. And if you do, then think about data mesh.
The way you describe this use case is very interesting because, yeah, maybe not all organizations are in this state where you have data and you do discovery and maybe shape the next set of data that the application produced, again, do hypothesis and maybe analyze, and then again, reshape the data over and over iteratively. And then maybe one day you will come up with a new insights and maybe new business lines as well, because the data has transformed so much with the scale of the discovery and also the scale of the hypothesis that the team does. So I think that's really a very interesting concept. I haven't experienced it myself because I haven't worked in this kind of organization, but thanks for sharing that. So let's move on to the principles. I think when I read all these data mesh concept that you share, you always come up with these 4 principles of data mesh. And when I read all of them, I find it interesting because you kind of like use other kind of framework or maybe approach from application development and mix it into the approach dealing with data. So maybe if we can go briefly one by one, right? The first one is you call it the principle of domain ownership. And this is something like applying domain-driven design to data. Maybe if you can tell us more about this principle.
Sure. You're right. Your observation is very correct that I wasn't as clever and as creative. I basically contextualized the things that I had seen working in, 24 years of my career in complex environments, in operational systems, and say, let's contextualize them. Let's apply them to the world of data. We've seen these principles work before. Why shouldn't they work with this bottleneck? They've solved previous bottleneck. So domain ownership is it's the same as what domain-driven design meant at the strategic design level group applications, which is you have these smaller business domain-oriented teams and groups of people that are collaboratively, cross-functionally working to solve business problems with technology. So they are not only responsible to develop applications and software to enable that business outcome, but they're also responsible for using and sharing data and for analytical purposes, for application of machine learning models. Again, back to digital streaming, if you have a team that is working on your player application and their job is to give the best digital experience to a user that's playing music or playing and liking and recording, whatever the interactions are, you are also responsible as a team, well, augmented perhaps with new roles and team members, for sharing that data in a way that data can be used to directly by some sort of an analytical workload. And that analytical workload might be a machine learning model that is being trained by your data and some other data from other domains. Or it could be the reports that we are producing in terms of errors and anomalies of this application so we can improve it over time. So that's the core of it, is that break down the responsibility of data sharing around the themes of organizations. So you have this infinitely scalable model. As you introduce new domains, you introduce new data sets that those domains can use and share, and give the responsibility of data sharing to people for analytical use cases, again, for this kind of cross-cutting use cases, to people that are capable to be responsible for it because they're so close to it. They understand, they know what this data about. Don't give that responsibility to someone downstream that actually doesn't know the domain, and it's very hard for them to keep cognitive load of knowing all the domains in their team's heads. So that's the first principle.
The way you describe it, it sounds intuitive, right? Yeah, why
Right.
not? But we came from the traditional approach where we have centralized team. They have to understand all the domain within the company or organization, understand the data model, the evolution of all data, and try to put them in one central place. But I think your approach here, your principle putting into a domain ownership, means that the domain team themselves is responsible for not just the operational data, but also the analytical data part, where probably they will transform their operational data, and responsible for sharing them for analytical purpose as well. And since they are the experts of the domain, they are probably the best person to come up with that kind of a data model. So I think it's
Exactly.
really intuitive after you explain it. There's also one concept that is on this principle, right? Where you mentioned that the data pipelines now is not a responsibility of a central team, but now it becomes an internal implementation of that domain team itself. So maybe if you can describe why this is so important.
Sure. Well, if data mesh is really successful the way I had imagined it, there no longer be any data pipelines. As in, if you go to the macro level, macro view of your architecture, you really shouldn't see data pipelines anymore between these domains, between the data products, which is concept that we can introduce in the next principle. So if you think about pipelines, what's the purpose of them? Pipelines are job-oriented, task-oriented computations that happen on some input from the data and transforms and put it on some output sink. And you repeat this task-oriented process until data gets transformed in a mode that somebody can use it. Usually there's structure around, okay, we need to extract information, we need to cleanse them, we need to model. And they're usually done in between the sinks of the data, outside of the source, outside of the destination, somewhere in between. So data mesh completely challenges that concept because we no longer work in this task-oriented kind of environment. We're working on this value-oriented, outcome-oriented environment, data product-oriented environment. So then the job of the transformation is really an implementation details of one of these data products in one domain. It's not something that happens in between. And it really falls into the similar principle of microservices that we had. In microservices world, this enterprise service was an anti-pattern, right? Because we want to localize logic and computation and complexity inside a boundary of a contract, abstracted within a service. The enterprise service wasn't doing that. So we came up with this idea of smart endpoints and dumb pipes. So your pipes are super dumb. They just transform data. And your endpoints are smart because they implement the logic behind the APIs. And that led to kind of more API thinking world. It's the same concept. So these pipelines are like the enterprise service bus analogy, if I choose, and they have the same challenges. So we've got to break them apart. The pieces that are relevant should go where they should belong. They can be implemented as pipeline if you want to within the implementation or other ways.
Again, very intuitive if you, again, compare with the application development, right? So ESB has long been an anti-pattern. So the same concept in data. If you want to connect two different data products, you should not create like a complex data pipelines. It should be just maybe transferring the data. When transferring the data, this is also another concept under this principle that you mentioned. There is now probably not a kind of like notion of one source of truth anymore about the data. You will have maybe shape of the data, multiple copies. Maybe it is in the domain team themselves, or maybe it's already copied to the other consumer of the data where they will use it for their use case. So why is this the case? Why no more single source of truth? I thought like in the data world, people love to have, hey, where's this single source of truth? Where is the data that I can trust?
Because a single source of truth is not a real thing. It just doesn't exist in real world. Okay, so let's unpack that. I don't intend to claim that we are becoming irresponsible about data and you will have contradictory copies of the data lying around and you have to kind of reconcile those. That's not the aim. The aim is we still want to be able to get a consistent view and understanding of the data, but we want to do that in a way that it doesn't slow movement. It doesn't slow value generation. It doesn't become a stale source of truth very quickly. We want to do that in a way that we support the chaos of reality of organizations. There are different teams moving at different pace. They generate different bits and pieces or properties of the same entity, but those properties come from different sources with different cadence. So we want to embrace that almost complexity and chaos, but yet create a system that gives the same outcome that a single source of truth wants to give, which is if I search for information about customer, even though that information comes from different places, I can understand a particular snapshot of the customer at a point in time has a set of consistent values. That's why I challenge this notion of single source of truth. So data mesh, what people don't actually read or understand is that has a lot of constraints and disciplines built into it. For example, the data that data nodes provide are read-only. They never change. They're temporal. They have 2 timestamps, bitemporal. So at any point in time, they are streamed across different nodes in a way that if some data arrives, new data arrives upstream, the downstream nodes that are transforming that or copying that and transforming it into a new shape of the data, they get notified. They have a responsibility to either react on it and generate a new slice of the data at point in time or not. And then also data mesh provides a means of stitching these policing concepts, like a customer that comes from the call center versus customer that comes from the e-commerce platform. The policing concept of the customer can be stitched together by the consumer because there are links that are created between those systems or between those data products. So there are a set of constraints. There are a set of operational disciplines like this policing linkage and bitemporality and immutable data that still results in the same outcome of a single source of truth. But it's designed for an inherently complex business model and operating model, if that makes sense.
And you mentioned it as a most relevant copy, right? So maybe you don't get the latest up to date. So it's like the concept of this asynchronous or maybe eventual consistency. Maybe you just need a snapshot of a data at a certain point in time. And yeah, the consumer will decide, okay, I just need this kind of data instead of always getting the latest.
Exactly.
Let's move on to the next principle, which is principle of data as a product. And I see that you are applying product thinking to this principle. So tell us more why it is important to treat data as a product.
Yeah, I think a mind shift that needs to happen when we put data sharing and serving and delighting the experience of people using data as a first class concern. It's also an antidote to the first principle, the problems of the first principle. So domain oriented data ownership, one can imagine, can lead to data siloing. I'm the player domain, I've got the data that I need to improve my application. So why should I care about sharing that and be responsible for consumers, which adds a ton of work? So data as a product tries to incentivize people to share that data, be part of an ecosystem that is generating value through data exchange and through data sharing. And again, put some discipline and constraints in place for that to be done effectively. So define such roles of people that are responsible for that, define success metrics for data as a product, define an architectural concept. If we define usability characteristics around discoverability, addressability, like all the things that make the experience of a data user really easy, really delightful, those need to be translated into structural architectural components that are built into this data as a product. So then you have kind of technology that needs to shift and change. So in short, it's an antidote to the problems that arise from the first principle and also really focus on, again, getting value from data. Who gets value from data? Data users do. So let's put them first.
I like the way you explain why the concept of a product is apt here, because you mentioned for successful products, you need these three attributes, which is visibility, valuable, and usable. And I think traditionally, again, we just treat data, okay, this is just a data. You go and figure it out. So sometimes it's not usable. So sometimes maybe the query language is different, the database technology is different because we all have these polyglot database technologies. Or maybe it's so ancient, right? Legacy technologies, we don't know how to deal with it. So I think if treating it as a product, we also need to think about the usability aspect. So I think that is definitely a key when I read about this principle. There are also a new role that is being created because of this concept of data as a product. You mentioned about data product owner and data product developer. So not all teams have these roles yet. Tell us more about the importance of these two roles.
Yeah. So if data product becomes a thing that we are creating, maintaining, operating, evolving, retiring when it's useless and nobody uses it, then there have to be people and roles to take that responsibility on. And it's very unfair, I think it's impossible to say to app developers whose work and consumer are very different personas, like they're serving the end user, to say, oh, now from here on, you also have this other responsibility. So not only you're serving these end users that are interacting with the player application and pressing buttons to make sure they have a responsive app and all of those great things, but also half of your day, you have to face around and face these data analysts and data science in different domains who want to use the analytical data that you generated. You've got to serve them too. It's impossible. You can't have two bosses. Like you can't serve these two purposes at the same time. So If there are superhumans that can do both jobs, so be it. That's fine. Maybe it is possible to kind of share your time and split your time that way. But nevertheless, you need to have a very explicit responsibility and accountability for that part of the job. If there are people that are pairing, like the data product developer and the app developer, they're pairing and they're collaborating closely, but there are two different people playing these roles, and that's fine too. Yeah, so unless these kind of idea of the data product doesn't happen out of good intention, we have to allocate space, we have to empower people, we have to keep people accountable and responsible, hence the roles.
Yeah, and also not to mention the skill set. They are totally
I
different
see.
technologies, different paradigms. I think it's very difficult to find people who can master both application development and also data engineering. I think for data to be also usable as a product, you mentioned about all other usability attributes like discoverability, addressability. It should also be understandable and it's trustworthy as well. And it can be interoperable. So imagine if you have multiple consumers, then they want to access your data, but they do have a set of constraints on how they would integrate with your data. I think interoperability is also a good concern that the data domain owner should think about. And that's why I think having a data product owner that maybe can define a set of requirements and maybe this kind of all usability concerns, I think that is key why these roles exist. So let's move on maybe to the next principle, which is about principle of the self-serve data platform. I think this is also interesting because you kind of like apply platform thinking to data mesh. Why we should have a self-serve data platform?
Yeah, I think it's an obvious one, but let's go deeper into it and say, maybe answer it. What is this data platform? So when we think about the roles of platforms in general, platforms are often shared kind of infrastructure on top of which you build domain specific solutions. So they're often like domain agnostic infrastructure that empower other teams to build solutions on top. So they're fairly horizontal, not really vertical so much. So in an organization that's implementing data mesh, now you have these domain teams. They have active folks in them, you have data product folks in them, and they're doing their daily job. Their daily job should be focused on delivering value based on the outcomes of that domain. Their daily job should not be focused on metalwork, creating kind of domain agnostic pieces of technology that they need. So I think platforms as mean to empower autonomous teams to lower their cognitive load, to do what they need to do more easily, they're wonderful, they're necessary. In terms of data mesh, the data platforms, many of them exist. There are lots of technology out there. They're built to give basic tools like, you want storage? Sure, I will give you storage. I can provision that for it. You want workflow processing? That's fine. I'll give you that. But the tool is low level for developing data products. So we need a new layer of the platform that really takes data product away. And this data mesh that I defined envisions treats it as a first class concern and hides away those details of, oh, I need a storage, a pipeline, or this and that. And it gives life to a completely new concept, this new concept of data quantum as a data product. So the job of that platform, the reason I put it in was making it feasible for independent domain teams to do data work.
And some of the attributes that you mentioned of this data platform is that it should be autonomous, interoperable, and domain agnostic. So I think one of the challenges when I was working with data related stuff also is that, yeah, you have all these tools like you mentioned, but bootstrapping all these tools takes a long time. You have to set up clusters, you have to maybe install things, dependencies, and on top of that, then you have to write code. You have to maybe understand the source, the sink, and things like that. And then you have to write the pipelines itself and then deploy it and things like that. Yeah, it takes a lot of effort just to come up with a very simple pipeline. And I could imagine having this kind of self-serve data platform, maybe something like a UI console where you can just go log in and, click, I want this data from this source and move it to my sink. And then it just creates everything for you. I think that will be a perfect scenario where maybe some of the tools not yet catching up. But yeah, hopefully one day we will reach that experience for the data engineer or maybe for business people. They don't even need to care about dealing with data engineers themselves. So you mentioned about this concept of self-serve data platform because one of the challenges of building this platform is that you will need to make it agnostic. So I think this is probably one of the challenges because we have so many different data technologies. So how should we think about building this platform so that it becomes agnostic? Because yeah, we have so many technologies, right? We have so many different shape of database technologies.
Yeah, I mean, it depends. The agnosticity, I guess, of the platform and its independence from underlying kind of technologies, the level of it depends on the appetite of an organization and how independent they want to be. So I think what we need is interoperability between the different technologies. So if we build a solution on top, and the solution requires data from across two different platforms, there is a level of interoperability that I can access data across two different clouds or across two different technology stacks. So at the minimum, we need a layer that creates that interoperability, even if the vendors themselves are not incentivized to do that right now. When it comes to underlying infrastructure agnostic, again, I don't think it's meaningful in all organizations because you end up with a like most common denominator of the set of features that are available on all the platforms. And that's not ideal. That's a lot of work and very little result. So I don't know if we need to be completely agnostic, but we have to have the pieces of it that enables interoperability and movement, moving from one to another and remove locking as much as possible. And those pieces are usually around cross-cutting concerns, right? How do I manage security? How do I build automation so that if tomorrow I want to move to a different set of infrastructure, my processes are automated and not hand cranked? I can kind of through automation facilitate the movement much faster. That's the way I think about this being tech agnostic as opposed to a nice layer on top. I don't think that's really realistic.
Speaking about cross-cutting concerns, so this also touching on the next principle, the last principle, which is principle of federated computational governance. It's quite mouthful to mention that, but it's taking care about all these cross-cutting concerns that you mentioned, things like, for example, security, policies, and things like that. You are kind of like applying systems thinking to this principle so that we can govern the data better. So share more about this principle because to some people, this might be hard to kind of like understand.
Yeah, it's a mouthful already. And if I could sneak in another word, I probably have called this principle of embedded federated computational governance. But I think Marty Fowler would have not posted my article if I did that. Yeah, so I think that the concept really is, again, an antidote to problems that arise from the previous principles, which is we need interoperability. We have now these disparate sets of data products, domain oriented, their own team, their own cadence, their own life cycle. How can we apply set of concerns that need to be standardized across all of them? And what's the best way to go about defining them? What's the best way to go about implementing them and observing and enforcing them? That leads to this principle. So as an example, if you need to have secure data or you need to have high quality data, let's go with high quality. Some sort of quality data, definition of quality, and then enforcing quality and sharing quality data. One way of doing it is say, okay, I'm going to put a quality control team, my governance team, in the process of generating every data. And these guys going to sit in the middle and verify at some point in that life cycle of the data if this data are acceptable to be shared. That's where system thinking comes to play. That system is going to have a massive bottleneck and it's not going to scale. So how can we achieve a defined level of quality without creating just necessarily just controls? We need the consensus or definition around what constitutes quality, as in what attributes do we use to describe the quality of data? Is it completeness? Is it integrity? Is it timeliness? Like is all of the above and others? So let's define those. And in that definition, let's have subject matter experts. Let's have domain people who actually know their data and how they can articulate quality involved in defining that. And once that's defined, let's automate it. Let's put it into the platform as a platform capability. The moment you are instantiating a data product, you will get out of the box a library or some SDK or something that gives you the ability to now calculate, capture, and share these quality metrics. And then you will have observability that runs across this mesh, across all of these data products and captures those information, shares that information, and also validates whether you are meeting the requirements of the quality that you've done. So that's the computational part. And the embedded part that I haven't put in the title is that this enforcing quality and measuring quality becomes an embedded concern in every single data product. It's not something that's smeared over and added later on. It's actually from ground up built in the data product itself. So it's embedded in there. So hopefully that gives a good example of achieving, I guess, well-oiled and cohesive mesh of interconnected data products through embedding policies, the standard policies in an automated fashion in every data product, and have the teams that are responsible for guaranteeing those policies involved in this defining what these policies are.
Yeah, if we can borrow things like from the application development, right? So we have this concept as well, policy as code. There are some tools in Kubernetes clusters where you can embed this kind of policy. So before you apply something, you will check towards the policy, and if it doesn't comply, it will reject. So data governance is probably one of the least sexy part of the data management, because there are things like PIA data security. Maybe it should not be leaked out, and it should not be exposed. Maybe things like data quality, right? How much lagging, for example, the data could be. And I think all this definitely needs to be governed, because otherwise it's really difficult. And you mentioned about observability, and you used the concept from SRE where you have also data SLO. So maybe if you can touch a little bit about this data SLO.
Yeah, absolutely. So data products, for people to trust your data, you need to share a set of real-time, almost, or at least as real-time as your data is, information to give people trust that this is a suitable data. So again, the dimensions of that, I think I unpacked it in the book and probably don't remember all of them on top of my head. But the dimensions of that are around quality, they're around timeliness, they're around completeness. There's a whole set of, often in the language of big data people, they call it metadata. It's a language I don't like and I don't want to use because it's just a catch-all bag of all things. But there are classes of really information, additional data that you've got to provide for what purpose, so that the people that want to directly self-serve use the product, they can self-assess if this data suits their use case or not. As an example, the distribution of their data. So if I'm doing an analysis or training a machine learning model for a particular use case, I'd perhaps like to have a very, nice bell curve distribution of the data and the samples that I can get for training that machine learning model rather than biased data. So how biased the data is. So these are, again, SLOs in the app dev are more about part uptime and response time and downtime and so on. And in the data world, the computational part of it still has those concerns, but the data part of it, it has a different set of concerns that defines the usability metrics of a data.
So thanks, Zhamak, for explaining all this. It seems like a very crash course of data mesh. I hope people do study about this data mesh, maybe from reading your book or your articles or watching some of your talks. I think it's really an eye-opening for those people who work with traditional data management. So thank you again for this. I have one last question before I let you go. So normally I ask these three things called three technical leadership wisdom. Maybe if you can share some of your wisdom for us, maybe to learn from your journey, from your experience, or your expertise.
Oh, it's a hard one. So maybe just a few things that I didn't do as well they can share, or things that maybe I did okay. I separate leadership from management. I'm a terrible manager. You don't want me as a manager, but maybe I'm an okay leader because I believe in a mission. I'm a very mission oriented person. So as a leader, you need to believe in your mission and create a mission oriented team and organization, and continuously through communication, through reinforcement of like embodying the right behavior to achieve that mission, reinforce that and remind your teams and keep realigning the team. Maybe there are different styles of leadership, but that mission-oriented, vision-oriented leadership resonates with me. I love working with people like that. And then to get to that mission, you have two ways of going there. You have a way of leaving maybe some casualties behind, like going in a way that not everyone can catch up, and a few wounded soldiers along the way. But you want to make sure that everybody's aligned. You need to think about every single member of the team, their needs, their pace, their specific hopes. And really, it's about not only having the vision and charging the path, but also making sure everyone can come along and think beyond yourself. That's probably an area that I need most help with personally myself, because my mission-oriented kind of leadership usually has casualties in the way. Your people need to be able to trust you and believe in you. You need to be very self-aware in terms of your strengths and your weaknesses, where you want to delegate and where you want to actually take something on. And if you're a technical leader, I personally respect technical leaders that still stay close to their craft. They still keep up to date with their craft. As we all know, the technology moves really fast. So you have to find a way to keep yourself relevant and up to date. And sometimes that means going really deep for a moment in time, get your hands dirty and coming back up. And of course, as your scope of leadership grows, your ability to go really deep diminishes because just time doesn't allow for that. So carving out space to go deep when it's needed, even for a very short period of time. I've seen some technical leaders do that. I admire people who can strike a balance between the depth and kind of the breadth of knowledge and relevance of their knowledge.
Wow, really beautiful. Thanks for sharing that. I think it speaks to some of the leaders where they are more vision driven as well, rather than managing people. So thanks for sharing that. So maybe Zhamak, for people to learn more from you, maybe about data mesh or just to reach out and follow up with the discussion, is there a place where they can reach out?
Well, as of now, really Twitter and LinkedIn would be the place. So I listen to both channels, but hopefully soon my company's website will be up and we will have jobs and we'll have places for people to reach out directly through that. But that's not up yet. But when it is, I will let you know and you can share with your network.
Really excited to hear about that. So many different data mesh technologies maybe will be coming from that. So thanks, Zhamak, for your time. Really a pleasure to have this discussion with you.
It was wonderful to be here, Henry. Thank you.
Thank you for listening to this episode and for staying right until the end. If you highly enjoyed it, I would appreciate if you share it with your friends and colleagues who you think would also benefit from listening to this episode. And if you're new to the podcast, make sure to subscribe and leave me your valuable review and feedback. It helps me a lot in order to grow this podcast better. You can also find the full show notes of this conversation on the episode page at techleadjournal.dev website, including the full transcript, interesting quotes and links to the resources mentioned from the conversation. And lastly, make sure to subscribe to the show's mailing list on techleadjournal.dev to get notified for any future episodes. Stay tuned for the next Tech Lead Journal episode, and until then, goodbye.